A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
My Weird Prompts is a community-driven initiative exploring how AI can fuel curiosity and uncover the fascinating ways our world works. GPU compute for this podcast is generously provided by Modal. Learn more at modal.com.
Have you ever noticed how the word serverless is one of the biggest lies in modern computing? It is marketed as this magical, frictionless experience where you just throw code at the cloud and things happen. But the reality for most of us is that you click a button, you wait 20 or 30 seconds for a container to warm up, and by the time the GPU is actually ready to do any real work, you have already checked your phone twice, looked out the window, and completely forgotten why you were there in the first place. It is a productivity killer disguised as a convenience.
It is the classic cold start problem, corn. It is the absolute bane of anyone trying to build responsive AI applications or interactive tools. If your user has to wait 15 seconds for a large language model or an image generator to even begin thinking, the experience is basically broken. But today's prompt from Daniel is about a company that has spent the last few years trying to kill that specific friction entirely. He wants us to dig into Modal.
Right, Modal. We should probably start by being transparent and clarifying that we are not just talking about this because they provide the GPU credits that keep our show running. Daniel is actually using it for his own heavy-duty video generation projects, and he is genuinely curious about how it stacks up against the traditional cloud giants like Amazon Web Services or Google Cloud. He is seeing a level of speed that he did not think was possible with serverless.
I am Herman Poppleberry, and I have been deep in their documentation and their architecture white papers for the last 72 hours. What makes Modal fascinating is that they did not just build another thin wrapper around AWS or a reseller platform for spare GPU capacity like some of the other players. Eric Bernhardson, the CEO, and Akshat Bubna, the CTO, decided to take the hard path. They built their own custom container runtime, their own scheduler, and their own file system from the ground up.
Which sounds like a massive amount of unnecessary engineering work, unless you have a very specific, very painful problem you're trying to solve. I mean, why not just use Kubernetes like the rest of the world? It is the industry standard for a reason, right?
Because Kubernetes was never designed for sub-second scaling of GPU workloads. Kubernetes is great for long-running web services, but it is heavy. It is slow to pull large images, and it is not optimized for the way GPU memory needs to be managed for AI. If you look at the architecture of Modal, they have a specialized file system called Modal Volumes, and a custom scheduler that can place a task on a GPU in milliseconds. When you run a function on Modal, it is not just spinning up a generic virtual machine and hoping for the best. It is injecting your specific code into a pre-baked, optimized environment almost instantly.
I remember when Daniel first started messing with this. He was coming from the model as a service world. You know the drill. You send a RESTA, PI, call to OpenAI or Anthropic. You get a response back, and you never have to think about the hardware or the drivers or the CUDA versions. Moving to Modal was a bit of a shock for him because it is more of an infrastructure, as code play. You are basically writing Python decorators like @app.function to define exactly what your environment looks like.
That shift from being a consumer of an API to being an architect of your own infrastructure is the biggest hurdle for most people. In the API world, you are just a tenant in someone else's house. In the Modal world, you are building the house. You have to define your Python dependencies, your system libraries, and even which specific GPU you want to use, whether it is an A100 or the new H100s. But the payoff is that you own the entire stack. You are not at the mercy of a provider changing the model weights under your feet or hitting a rate limit that ruins your production pipeline right when you need it most.
It is that control that Daniel keeps raving about. But before we get too deep into the technical weeds, we should talk about the company itself. Eric Bernhardson has a pretty legendary pedigree in the engineering world. He was the 40th employee at Spotify and the creator of Luigi, which is a very popular data orchestrator, and Annoy, which is a library for approximate nearest neighbors. He was also the CTO of Better.com, so when he says he wants to fix data-intensive workloads, people tend to listen.
And the market is definitely listening. Modal reached unicorn status late last year after an $87 million Series B led by Lux Capital. They are currently valued at over $1.1 billion. That is a lot of pressure for a New York-based startup, but it shows how desperate the industry is for efficient, scalable compute. We are in the middle of this massive shift where everyone is trying to figure out how to run these models without going bankrupt.
Speaking of not going bankrupt, we should probably talk about how we actually use this thing for the show. Because before we moved our text-to-speech workflow over to Modal, we were looking at some pretty depressing bills. We were trying to run custom models like XTTS-v2 to get the voices just right, and the traditional cloud options were not great.
We were looking at over $500 a month just to keep a single mid-tier GPU instance running 24/7. And the tragedy was that we only actually used it for maybe 3 or 4 hours a week when we were processing episode scripts. The rest of the time, that silicon was just sitting there in a data center somewhere, burning money and generating heat for absolutely no reason. It was the definition of inefficiency.
It was like paying full rent on a luxury apartment in Manhattan that you only visit for an hour on Tuesday afternoons. It makes no sense. Now, with Modal, when we hit the button to generate the audio for this episode, Modal spins up a cluster of GPUs, does the work in parallel, and then instantly scales back to 0 the moment the last sentence is rendered. We only pay for the literal seconds that the GPU is active.
And the pricing is actually quite aggressive now. As of late, March 2026, their effective rate for an NVID IH100 is roughly $3.95 per hour, but remember, that is billed by the second. If you compare that to a bare metal provider where you often have to rent the card for at least an hour, or even commit to a month, the math starts to look very different for bursty workloads. If your task takes 45 seconds, you pay for 45 seconds, period.
You mentioned something earlier when we were prepping for this called the 51% rule. Is that like a legal thing or just an engineering heuristic?
It is a financial heuristic that has gained a lot of traction in the industry lately. The idea is that if your GPU utilization is consistently above 51%, meaning the card is actually doing work more than half the time, it is actually cheaper to go buy your own hardware or rent a dedicated bare metal instance. If you are running a massive training job that is going to last for 3 weeks straight, you do not want serverless. You want a dedicated rack. But for inference, for internal tools, or for anything that fluctuates throughout the day, if your utilization is below 51%, serverless is almost always the winner because you are not paying for the idle time.
I think that is where Daniel found the most value. He's been doing these video generation experiments where he needs to generate, say, 100 different clips to find the one that actually looks good. If he used a standard API, he would be sitting there for an hour waiting for them to process one by one because of concurrency limits. On Modal, he just maps that function across 100 containers simultaneously.
It is massive concurrency. You are essentially renting a supercomputer for 60 seconds. Generating 100 clips takes almost the same amount of time as generating one. That is a fundamental shift in how you think about creative workflows. You stop optimizing for the cost of a single run and start optimizing for the speed of the entire batch. It changes your iteration cycle from days to minutes.
But there is still that cold start issue we talked about at the beginning. I mean, if he is doing something interactive, even a 10-second wait feels like an eternity in the modern era. I saw something in the recent updates about GPU snapshots. How does that actually work? Is it just caching the image?
This is one of the most significant technical updates we have seen this year, and it is currently in alpha and beta testing. Normally, when a container starts, it has to load the model weights from the disk into the VRAM of the GPU. If you are dealing with a large model, that can take 15 or 20 seconds just to move the data. Modal's GPU snapshots basically take a literal picture of the VRAM state, including the model weights and the CUDA kernels that are already initialized.
So instead of reloading and reinitializing the whole thing, it just resumes the state.
It injects that state into the GPU almost instantly. They have brought cold starts for heavy models like Comfy UI or large text-to-speech engines down from 15 seconds to under 3 seconds. For something like a custom application or a specialized video diffusion model, that is the difference between an application feeling broken and feeling like magic. It makes serverless viable for real-time applications that were previously impossible.
I want to pivot to something Daniel mentioned about architects. He has been talking to some friends in the design world who are trying to move their rendering and simulation workflows to the cloud, specifically people using Rhino and Grasshopper. That seems like a much harder nut to crack than just running some Python code, because those tools are so tied to specific operating systems.
It is a massive hurdle because of the operating system mismatch. Most architectural software, specifically Rhino and its compute engine, is historically tied to Windows. Modal, like almost all high-performance compute platforms, is a Linux-native environment. You cannot just drop a Windows installer into a Modal container and expect it to work. It is like trying to put a square peg in a round hole.
So are those architects just out of luck, or is there a way to bridge that gap?
There are two main ways to do it, but both require some engineering effort. One is using the Rhino 3DM library, which is the open source version of the OpenNURBS geometry kernel. You can run that on Linux to do geometry processing, like calculating intersections or generating complex paths. But if you want the full rendering power of Rhino's Cycles engine, you have to use a headless version compiled for Linux.
That sounds like a lot of work for someone who just wants to see what their building looks like in the sunlight, or run a structural analysis.
It is, which is why we are seeing a shift where Modal acts as a geometry processing worker. The architect stays in their Windows environment on their local machine for the design work, but they offload the heavy computational tasks like massive structural simulations or environmental analysis to a Modal cluster. The local machine sends the data, Modal spins up 1,000 GPUs to run the simulation in parallel, and sends the results back. It is about using the right tool for the right part of the job.
It is funny because we have seen this pattern before. People think serverless is just for simple webhooks or resizing images, and then someone comes along and uses it to render a city or simulate a drug molecule. It really comes down to whether you are willing to learn the Python native way of doing things. You have to be comfortable with the code.
And that is the core of the Modal philosophy. They are betting that the future of AI development is not going to be built by people clicking buttons in a dashboard or just calling generic APIs. It is going to be built by engineers who treat their infrastructure as part of their code. That is why they have reached that unicorn status. They are providing the tools for the people who are actually building the next generation of software.
It is a bold bet. $1 billion valuation for a company that basically helps people run Python scripts on GPUs. But when you look at the scarcity of compute, it makes sense. They are also aggressively updating their hardware pool. They were among the first to get NVID, IA Blackwell B200s, and H200s into their serverless pool this year.
If you want to do frontier-class inference on the latest silicon without signing a 3-year contract with a data center or buying $1 million worth of hardware, there are not many other places you can go. Modal gives you access to the most powerful chips on the planet for a few dollars an hour. That democratization of hardware is a huge deal for small teams.
I guess the question for the listener is, at what point do you make the switch? If you are just playing around with Midjourney or ChatGPT, you obviously do not need this. But if you're building a product, where is the tipping point?
The tipping point is when you find yourself frustrated by the limitations of a third-party API. Maybe it is the latency, maybe it is the cost at scale, or maybe you need to use a very specific fine-tuned model that no one else hosts. Once you need that level of control, you have to choose between managing your own servers or using a platform like Modal. And if you choose the server route, you better enjoy spending your weekends debugging CUDA drivers and worrying about thermal throttling.
Which is exactly what Modal is selling. They are selling you your weekends back. They handle the drivers, the orchestration, the networking, and the scaling. You just provide the logic. It is a compelling pitch for anyone who has ever lost a day to a broken environment configuration.
We should probably talk about the takeaways for people listening who are considering this. The first step is to audit your current GPU utilization. If you are paying for a cloud instance right now, look at your logs. How often is that card actually at 100%? If it is sitting idle for more than half the day, you are literally throwing money away. You are subsidizing the power bill of a data center for no benefit to your project.
And do not be intimidated by the infrastructure as code aspect. Yes, you have to define your environment in Python, but once you do it once, you can reuse that image forever. It is a one-time tax for a lifetime of flexibility. You can define your CUDA version, your specific version of PyTorch, and all your dependencies in a few lines of code.
The other thing to look at is the batching potential. If you have any process that currently runs in a loop, see if you can parallelize it. That is where the real magic of serverless GPU compute shines. You turn a linear problem that takes an hour into a parallel one that takes 60 seconds. That kind of velocity changes how you think about experimentation.
I think that is what Daniel liked most. He mentioned that once he got over the initial learning curve, he could go from an idea to a deployed scaling application in about 20 minutes. That kind of speed is addictive. It allows you to try weird ideas that you would otherwise ignore because the setup time was too high.
It is the democratization of the supercomputer. We are living in the inference era now, as we talked about in episode 1544. More than half of all AI infrastructure spending is now going toward keeping models running rather than just training them. Platforms like Modal are the backbone of that shift.
It is a massive shift, and it makes me think about the long-term implications. If the cost of inference continues to drop and the speed continues to increase, the barrier to entry for high-end AI applications is going to vanish. We are going to see small startups launching tools that rival what the giants are doing.
We are already seeing it. Small teams are building video editing tools and architectural simulation platforms that are incredibly powerful. They are doing it by leveraging these serverless platforms to get massive scale without the massive overhead of a traditional DevOps team.
I do wonder, though, if we are going to see a world where this becomes even more abstract. Like, will I ever reach a point where I do not even have to write the Python decorator? Where the system just knows when I need a GPU and provides it seamlessly.
We are heading that way. If you look at the progress from 2 years ago to today, the friction has dropped significantly. We went from waiting minutes for instances to waiting seconds, and now, with those VRAM snapshots, we are looking at sub 3-second response times. The goal is to make a GPU feel as ubiquitous and as fast as a standard CPU function.
It is a bold vision, especially when you consider that the hardware itself is becoming increasingly scarce and expensive. If Modal can keep their prices competitive while providing that level of performance, they are going to be a very hard target to hit for the traditional cloud providers who are still stuck in the virtual machine mindset.
One thing that often gets overlooked is the developer experience beyond just the GPU. Modal has things like Modal Secrets for managing API keys and Modal Volumes for persistent storage. It feels like a cohesive ecosystem rather than a collection of disjointed tools you have to stitch together with bash scripts and prayers.
I think we've covered a lot of ground here, from the custom runtime architecture to the economic 51% rule, and how this is actually changing the way we produce this very show. It is a fascinating time to be watching this space.
It really is. The democratization of this kind of hardware is going to lead to some very strange and wonderful applications in the next few years. We are just scratching the surface of what is possible when you give everyone access to a supercomputer for a few cents a second.
Well, I for one am looking forward to the day when my cold starts are so fast that I do not even have time to check my phone. I might actually have to stay focused on my work, which is a terrifying prospect for my attention span.
You could always just use that extra time to ask me more probing questions about container runtimes, corn.
Do not tempt me, Herman. I have plenty of them, but I think we should probably wrap this one up before you start explaining the nuances of CUD, a kernel optimization, and lose half our audience.
Probably for the best. We will save the kernel talk for the after show.
Thanks as always to our producer Hilbert Flemingtop for keeping the gears turning behind the scenes. And a big thanks to Modal for providing the GPU credits that power our text-to-speech and automation pipelines. We genuinely could not do this show at this scale without that infrastructure.
If you found this technical deep dive useful, we have covered similar territory in the past. Check out episode 484, The Silicon Sharing Economy, for more on the early days of serverless GPUs, or episode 1227, where we discussed the Mojo programming language and the quest for AI performance.
This has been My Weird Prompts. If you are enjoying the show, a quick review on your podcast app really does help us reach new listeners who might be as nerdy as we are. It makes a huge difference in the algorithms.
You can also find us at myweirdprompts.com for our full archive and all the ways to subscribe to the feed. We have got all the show notes and technical links there as well.
We will be back soon with another prompt from Daniel. Until then, stay curious.
Goodbye.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My Weird Prompts, that's the flows from slow.